Welcome back to linear algebra. Let's jump in on key. Two flashcards to do. What do we got? If A is an invertible matrix and K doesn't equal 0, how might you write the inverse of the resulting matrix of K times A as a scalar multiple of the inverse of A? I think it's going to be the inverse of K times the inverse of A. There we go. If A and B are square matrices, what must be true for the equation? The sum of A plus B squared equals A squared plus 2 times AB plus B squared. A and B must commute. Okay. So there's that. I'm going to grade the work I did yesterday, and then I'll go from there. All right, guys, so I got the proof valid and the 3 true or false correct, so good work. Again, proof writing, my notation and presentation can be improved, but the validity is good, so that's all I'm going for right now. Anyway, so now we just have the working with technology problem, and then we're done with the first pass of section 1.5. So I'm going to go ahead and continue working on that problem, and then maybe start a second pass if I have time. So talk to you in a bit. Okay, we finished the technology problem, which gave a 4x4 matrix. And it basically said if you partition them into 2x2s, A, B, C, D, then you can use this these basically expressions with like inverses multiplied by and subtracted like arithmetically to other matrices, partition matrices. Then you can find the inverse using that. So basically, this is the 4x4 we're given. Here's the 2x2 partition. And then you can use these formulas to calculate the different partition matrices and then expand it essentially to a 4x4 again. So I used MATLABs to do that. Did it work? I don't know. We're going to check tomorrow. I could have checked it by hand to see if the inverse was correct, but it's potentially correct. 2 of the partition matrix were identical to the OG one, so that was kind of a little red flag, but we'll see if I got that right. I decided ultimately just to check tomorrow rather than spending time to do it by hand, because I think it's a better use of time. So we started around 2 of 1.5. So this was just 2 was a matrix, an elementary matrix. Yeah, it was simple. It was a 2x2 matrix. It was easy to know. 6 was basically saying, look at this look at this elementary matrix, identify the row operation corresponding to it, which is multiply the top row 1 by -6, and then identify that E times A is the same as A with that corresponding row operation. So we multiplied -6 through the top row of A, and then we times E by A, and they're the same, so that is correct. And yeah, that's actually all we got through. So we should probably blaze through 1.5 in the second round. So I could see this being done with 1.5 and into 1.6 within maybe 2 days. So yeah, that's it for today. I will talk to you tomorrow. See ya.